Symmetry is an important characteristic of graphs that we'll look for as we're analyzing equations in graphs. Some graphs are symmetric about the y-axis. We're going to look at this three different ways. The definition of symmetry about the y-axis is that for any point on the graph xy, there must also be a point on the graph that's negative xy. Well, what does that mean? Let's look at this graph. Here I have a point over at 2, 4. In order to follow this definition, if I have a point at 2, 4, there must also be a point at negative 2, 4 to be symmetric about the y-axis. Here's negative 2. Here's the point. For every point on this graph, there is a point that's exactly the same distance away from the y-axis, but on the opposite side. Here, and here, and here, and here. In fact, anywhere on this graph, if you draw a horizontal line across it, you'll run across a pair of these points. So that's one way we can think about symmetry. Another is just by looking at the graph. You should be able to fold it in half vertically. Imagine here's that axis of symmetry right here. If you folded this on the axis of symmetry, the graph would line up right on top of itself, and that shows that it's symmetric around the y-axis. The third way we can tell is using algebra. The equation of this graph is y equals x squared. This graph is symmetric around the y-axis if you can plug negative x into x and you still get the original equation back again. Let's try it. So in this case, we'd put in negative x and simplify, and you get the original equation back again. Those are the three ways that we look for symmetry. How about symmetry about the x-axis? Well, here's another parabola, but this one's sideways, right? So we've got x equals y squared. In this case, we can tell by points if for every point AB that's on the graph, there is also an A negative B on the graph. So just like before, if you choose any point on the graph here, straight across the x-axis, there should be another point that lines up with it but has the opposite y-coordinate. So let's take an example. We know that the point 4, 2 is on this, right? So if 4, 2 is on the graph, then according to this rule, 4, negative 2 should also be on the graph. So lined up with 4, here is another point, and it's down at negative 2. So now let's talk about the graph. This graph has an axis of symmetry that's horizontal. It goes straight down the middle. This way, it's the x-axis. If we folded this graph on the x-axis, the lower half would line up right on the upper half exactly, and that shows symmetry about the x-axis. Finally, we can use algebra. If we take our equation, and this time, if we plug in negative y to y, we should get the original equation back again. If we simplify that, there you go. Original equation back again. And that is symmetry about the x-axis. Now let's look at symmetry about the origin. This is a little more complicated to think about. You can tell that there's some symmetry going on here because we could fold this a few ways and these two graphs would line up on each other. This is a rotational symmetry, so if we rotate this around the origin and the graph lines up on itself before we go 360 degrees around, then this has symmetry about the origin. But let's look at what happens with the points. In this case, if we have some point AB on the graph, then there must also be a point negative A, negative B, or rather opposite of A, opposite of B on the graph. So if I tell you that this is the graph of y equals 1 over x, all right, so let's say when x is 2, y is 1/2. Well, if that's true, then negative 2, negative 1/2 must also be on the graph. Let's see if that makes sense. Let's say this is 2, 1/2 right here. So if we go over here to negative 2 and we go down similar amount, here it is. Let's say we don't know what the equation is, and I just give you a point that's on the graph. Like, let's say I give you -3, 4, and I say that's on the graph and it has symmetry about the origin. What's another point? You just think opposite of -3, opposite of 4, so there must also be a point at 3, -4. All right, now let's look at the graph. This time, this graph could be folded along the line y equals x. And it will match up. And finally, can we show symmetry with algebra? In this case, we should be able to plug in the opposite of x and the opposite of y and have it return to the original equation. So let's say if we have y equals 1 over x, and we do that, we get opposite of y is equal to 1 over opposite of x. Well, that doesn't look the same, but we could just multiply both sides by -1, and then we would return to y equals 1 over x. The original equation comes back. A final note, most equations do not produce symmetric graphs of any kind. We've focused so much on symmetry that I don't want to leave you with the impression that that's the most common thing, that there's always this symmetric relationship between the x coordinates and the y coordinates. There's lots of equations that are very useful, like polynomials and things that we're going to be using throughout the year that don't have any kind of symmetry. So that should give you a really good place to start, and now you should be ready to try the homework.